Welcome to today's lesson. In our last lesson, I said that in the next lesson, we'll talk about the equation of a straight line. Okay. Before we talk about the equation of a straight line, there are a few things that we should know. Okay. What is the equation of a straight line? Okay. A straight line is a graph of the linear function. This function is expressed as f of x is equal to mx plus c, where m is the gradient and c is the y-intercept. That is where the line crosses the y-axis. We can simply write this as y is equal to mx plus c, where f of x is the same as y. M, as I said, is the gradient or the steepness of a line or the slope of a line. And C is the y-intercept, where the line cuts the y-axis. Okay, so for us to talk about the equation of the straight line, we first of all have to know what the gradient is. Okay, so let's talk about the gradient. The gradient of the line joining 2 points. Let's take, for instance, the point 1, x comma y, which is x1 comma y1, and the second point q, x2 comma y2. Okay, now let's plot these 2 points on the Cartesian coordinate plane. We have p and q, x comma y, x comma y. Okay, this is x1 comma y1, and here we have x2 comma y2. Okay, now we join this line. Okay, we draw the line joining these 2 points. Okay, as you can see, we have x1 here and we have x2 here. We have our y1 here and y2 here. When we join these lines, we construct a right angle triangle. Okay, as you can see, we have the distance here, x2 minus x1 and y2 minus y1. This can simply said to be change in y. Okay, and this can be said as change in x, delta y and delta x. Okay, so what is the gradient? The gradient is the ratio of the change in y, okay, to the change in x, okay, which is delta y upon delta x. Okay, now this can also be said to be equal to the tangent of theta. Theta is this angle. Okay, it can be said to be the tangent of theta, which is this angle. Okay, what is the definition of tan theta? Tan theta is opposite over adjacent. Okay, when you look at the SOHCAHTOA, we remember this in high school. Okay, opposite, adjacent. Okay, for tan theta. So what is the opposite? The opposite is delta y. Okay, and the adjacent is delta x. Okay, so the gradient is simply the tangent of theta. Okay, this angle here is the gradient. Okay, all right. Gradient can be expressed by writing y2 minus y1 divided by x2 minus x1. The order does not matter. You can as well write it as y1. You can also write it as y1 minus y2 divided by x1 minus x2. It is the same as tangent of theta. It gives the same answer. Okay, so this is the formula of the gradient. Okay, it is simply the change in y divided by the change in x. Okay, so when this angle is 0, it means that there is no gradient. The gradient is 0. Meaning when the tangent of theta is equal to 0, it means there is no gradient. All right? Yes. When is this tangent of theta equal to 0? When this line PQ is the same as this line, okay? So this line will be coming down, 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 down until it reaches this line, all right? And the tangent will be 0. So the gradient of a line is simply the angle tan theta, all right? Yes. And this one can be solved by this equation, all right? That will be the gradient of a line. Now let's see the examples. Find the gradient or slope of the straight line joining each of the following points. We have A 4,3 and 2,7, then B 3, -2 and 1,4. Okay, and part C, find the equations of the straight lines joining points in A and in B. Okay, so for A, all right, we have 2 points which are 4,3 and 2,7. So y2 minus y1 over x2 minus x1. Okay, we are finding the gradient. So we take y2 to be 7 and y1 to be 3, which is here. This is y1. Divide by x2 as 2 here minus 4 as x1 here. Okay, these are x coordinates, these are x coordinates, and these are y coordinates. All right, so 7 minus 4 is 7 minus 3 is 4. 2 minus 4 is -2. Here we have -2, all right, as the gradient. Or we can simply do it the other way around by choosing 3 to be the starting point. Okay, so we say y1 minus y2 over x1 minus x2, so which is 3 minus 7, okay, and 4 minus 2. So here we have -4 and 2. It's the same as which is -2. The answer is the same. Okay, so this is the gradient of this line joining 2 points. Okay, then let's do B. For B, we have 3, -2 and 1,4. So I have plotted these points on the Cartesian coordinate plane. We have 1,4. This is the point. We have 3, -4, -2. Okay, 3, -2. All right, I made a mistake. Now we join these points. This is the line. Okay, so what is the change in y? Change in y, we can count the number of boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Change in y is 12. Then what is the change in x? 1, 2, 3, 4. That's 4. Okay, all right. This is 12 divided by 4 is 3. Okay, the answer is 3. But the gradient is -3 because the line is slanting this way. Okay, if the line slants in this direction, the gradient is negative. Then we'll talk about that later. If the line slants in this other direction, then the gradient is positive. Okay, since the line is slanting in this way, the gradient is negative. Or we can find it by the formula y2 minus y1 over x2 minus x1. Okay, which is our y2 is -2, y1 is -4. No, 4. Okay, -2 minus 4. Okay, then our x2 is 3. Okay, minus 1. Okay, 3 minus 1. So we have -6 over 2, which is -3. So this is our gradient. It's the same, -3. We have solved it by the formula or by just counting the number of boxes. Okay. Then part C, let's find the equation of a straight line. Okay, in A. Okay, the equation of a straight line is y is equal to y mx plus c, where m is the gradient and c is the y-intercept. So we can pick this point. Okay, what is y here? Y is 3. Okay, what is the gradient? Is -2, so we put -2 here. What is x? X is 4, we put here. So when we perform the operation, we have 3, we have -4, and we have c here. So c is equal to 11. That's the y-intercept. So y is equal to mx plus c. So y is equal to, what is the gradient? Is -2. Okay. Then the y-intercept c is 11. So the equation of the straight line is y is equal to minus 2x plus 11. Oh, this is the same. Okay, this is the same equation. We pick this point. We can pick this one if we choose. Okay, 2,7. So y is 7. The gradient is still -2. Okay, so y is equal to mx plus c. So 7 -2 times 2, x is 2 here, plus c. So 7 is equal to -4 plus c. So c is equal to 11. Okay, y is equal to mx plus c. Y is equal to -2. This is the gradient, x plus c, which is 11. So this is the equation in A, the equation of the straight line joining 4,3 and 2.2,7. Okay. Then for B, we can pick this one. Okay, to find the equation, which is y is equal to mx plus c. The gradient here is -3, which we found. All right. Then -2 as x. Okay. Then the gradient is -3. All right. Then 3. This is x. So we have -2. Then we have +9 plus c. So we have c is equal to 9 minus 2. So c is equal to 7. So y is equal to -3 plus 7. Okay. Or we can choose 1,4. When we choose 1,4 and the gradient is -3, we have y is equal to mx plus c. So y is 4, then gradient is -3, then x is 1 plus c. Okay, so 4 is equal to -3 plus c. So c is equal to 4 plus 3, c is equal to 7. 7. So y is equal to -3x plus 7. These equations are the same, so it does not matter which points you choose. Okay, the answer will be the same. All right. So this is, what we can accommodate for now. We'll continue next time with the equation of the straight line, because there is more to talk about the equation of the straight line. Okay. Yeah. Okay. Thank you for your time.